Gracias por la oportunidad de hablar sobre el poder de las pruebas en el túnel de viento. No puedo practicar mucho español. Agradezco tu paciencia. So, thank you for having me. I'm sorry my Spanish is very rusty. I haven't studied it since high school. But I work in wind tunnels where we are able to use very sophisticated tools to optimize the wind loads on facades. So they're very unique because we actually model the turbulence and the velocity profile in the tunnels with the local surroundings. So these are the really important features that we use to shape the wind. So when you're down at the ground, the velocity is 0. But when you think about where planes fly, it's much faster. And that shape is unique. And we're actually using different things on the floors and in the inlet to make sure that we can model that shape. No, this one. Gracias. Okay. So we use pressure taps, pressure measurement points, distributed across the building to measure the local pressures, and then we'll incorporate that with the wind climate as well. Typically, we're using anywhere between 600 and 1,000 taps for a building. Es muy importante medir las presiones sobre las discontinuidades y que normalmente los códigos de construcciones no les manejan bien. So we use the wind loading chain, which is from Alan G. Davenport. It was developed back in the 1980s and 1990s, and we're basically using all of these links to evaluate the wind tunnel pressures. So there's climate, there's also the influence of terrain, which is sometimes natural terrain, such as here in this region, but also local buildings. The aerodynamic effects, if the building is going to move in the wind, as well as dynamics and criteria. The criteria would be the local code or design wind speed. Each one of these is very important to determine the wind loads. However, when you're using a code, it's much more simplified. So we're able to dig in and do these evaluations for each pressure tap to get a better idea of what's happening. El video muestra la variación significativa de las presiones medidas y la aerodinámica compleja. So this is an animation of the velocity pressures from one wind direction that we test. Blue pressures are signifying suction, which is pulling away from the building. Red pressures are into the building. So you can see that at each timestamp, things are changing significantly. And you have those quick things where there's a blue and it's a very high pressure, okay? And so we're working with all of this to try and understand, and sometimes you get those really strong pressure gradients that will translate into large loads. But we tend to test 36 directions around the compass, and this is just measurements from one of the directions from our wind tunnel studies. So from all of that information that we have in a time series, we're then going to determine the peak pressures, and we're going to use those to develop site-specific, project-specific recommendations, and they tend to be much more detailed than what you would get from a code. So you can see in this situation, there's a red hotspot, and that translates to a higher pressure. But because we have the spatial variation, we can tighten it down so the high loads aren't going to punitively affect the whole building. So design pressures from a wind tunnel study typically are lower than what's predicted by code, but it can also highlight where there are inconsistencies in the code or maybe even some risks in the code. Codes don't handle towers on podiums very well. And so there's going to be significant regions where there might be some variations from what we would expect. In this situation here, you see that there's a couple areas that are highlighted in orange. That's where things were higher. Everywhere else, there's the possibility of saving cost and saving materials. The best opportunity for reductions are things that are exposed to wind on both sides. So we think of parapets and balconies, anything that has pressure from the wind on both sides. Codes tend to handle those together. And so when we can do a wind tunnel study, we can often have the pressures, which can be a significant savings from structural steel as well. This is probably the most important slide. Este es un ejemplo de la reducción de costas para una puebla en el túnel du viento en comparación con una fachada diseñada según código. So this is an example of the savings that can be achieved when doing the wind tunnel test as opposed to designing from code. And so this particular building was about $40,000 US for the wind tunnel study, and it was $1.2 million that was saved in a combination of the glass and the supporting structures. So there's huge potential, but we do need to make sure that the facade manufacturers and designers can take advantage of that, but there's significant potential from wind tunnels. We also do complementary studies once we have the data. I do a lot of furniture studies because sometimes we're putting furniture up on the top of the building and it can fly. Sometimes these are in Florida where the wind speeds are high, sometimes they're not. Also rooftop pavers and door operability. So I'm actually on time, so we do have time for a couple of questions if you have any in. Gracias por la oportunidad.
Gracias, Sara. Han hecho un esfuerzo por poder comunicarse, lo cual me parece digno de destacar. Preguntas del público. El micrófono. Ahí está levantando la mano.
Hello, it was very nice to hear your exposition. And it's very, very, very helpful the last...
Por favor, presentate.
Perdón, soy Mauricio Mendoza, de Aluvisa. Hacemos fachadas de aluminio y vidrio, ¿no? It's very interesting, the last part when you talk about the savings, about what happened if you do the wind tunnel. We have done in the past important projects like Torre Mítica, for example. It's a very, very, very typical example of what you say, that in a tower of 60 floors, if you go by code, you are going to be with a 4.5 KPS loads, and at the end with the wind tunnel, because the shape and that kind of stuff, the design was 2.5, no? So this is a lot of savings. But do you have an exercise selling, because of course in a high-rise tower, 60 floors, of course you have a lot of savings because the code. Do you have an idea of how much the volume of a project can be? What is the difference between a project that, I don't know, 10-story project is not very convenient to have a wind tunnel? Do you have you explored any type of analysis that way? When is affordable and very helpful to use the wind tunnel, and when is not too much? So when is not too much recommended? Do you have any of?
Great question about when to trigger a wind tunnel study based on the potential for savings. It's really up to the design team. If there's lots of glass, there's obviously more opportunity for savings. I have done everything from a single-story home all the way through to high rises. And every study that I've had has had measurements that are below code. So if you have the opportunity to optimize, and if your whole design team is willing to do that, then there's no limit to a project that can benefit from wind tunnel.
Okay, thank you.